Hello, this is Durwell King with Sampson Community College. The class is ELC 118, National Electric Code. This is Thursday, October 21st, 2021. And we are picking up in our book. Well, before I start, you see on the screen there that we are doing spring registrations now. So if you want information on what's available, contact me and I can email you a list of classes that are available for the industrial program or the electrical program, and we can get you registered as soon as possible. They would like everybody to get registered within the first 2 weeks if possible, so they can have an idea about enrollment. So you can let me know at your convenience, and I can actually register people remotely. You don't even have to be here to do it.
I gave Marty the 2 classes I need. Right. To make sure that's all I needed to graduate. Right. And he done it for me already.
Yeah, you can tell me. You can pick what you want and tell me that's what you want. And if you ain't got time to stick around, I will key all that in when I get the convenient moment to do it. So if you got a press schedule, that's fine. Just get you one of these here, start with what you know you can do, and I'll take care of the rest of it. Yeah. Yeah. Hunter, I got a list of classes here just for next semester time. It shows what's available. 3 pages here if you want one of them. 3 pages there, and then this shows you about dates as far as due dates and stuff. How you doing today? All right. Okay, so we're gonna click right on to Article 230, 230.46. Splice conductors. Let's get our video. Set. Camera. There we go. Okay. Got the end a little bit. This camera, every time I move it, it wants to flake out. Here we go. Okay. If you notice up here, they got a thing that lets you splice into a wire and do a tap off for something else. So services, spliced and tapped service conductors. Pressure connectors and devices for splices and taps must be listed, which means it's got to be something store-bought that's made for it, that's approved by UL. It has to be an approved device that won't damage the wire when it taps into it, when it cuts the insulation. So things like that, they'll actually pierce in through the insulation and they'll give you a tap without actually cutting the wire. It actually cuts it for you. Power distribution blocks installed on service conductors must be listed and marked as suitable for use on the line side of service equipment or equivalent. So that all boils down to something that needs to be store-bought and approved and listed, not a homemade thing. And protection against physical damage underground. Now here they got a box. So they've got like a PVC box of some type, and they've got their splices that are underground, but they've got a box that's like a watertight box that's listed for that. And it looks like they've actually got some cement or some rocks under that box. So now if you notice here, they got conduit coming out of your service there, going underground for 24 inches. And then it's actually just direct buried from that point there. Now, when they put my generator in the house, I had a generator put in, automatic transfer switching off. When they installed it, they did like that. They did the conduit where it got under the ground, and then from then on out, it was like, direct buried conductor, because the wire is actually listed to be direct buried, and you want protection down to say 24 inches below the surface. And then from then on out, it's not bare wire buried, It's listed, and that's the way they do it. And again, if you got power running underground, they call that a underground service lateral running this way. And as far as protection goes, you see the 300.5. The 300.5 tells you the depth that we looked at the other day. It tells you how far down you got to dig. 300.5. And I think I put, let's see, did I stick that in there? 300.5. Flip in your book. If you flip in your book to 300.5, see if that table is in there. $300.5. Yeah, it's on page 335. That table is telling you the depth, how far down you got to dig when you do underground wiring. Okay, so that's what they're referring to there for protection. Where it's subject to physical damage, you got to protect it by one of these methods here. Now here is where you got a snow plow here that could hit that conduit. So you got to have you got to have it definitely in conduit for sure. So RMC is rigid metal conduit. That's the really thick wire stuff. IMC is intermediate. That's a little bit thinner than rigid. Schedule 80 PVC. Schedule 80 is the thickest PVC, to where Schedule 40 is thin wall PVC. So you can't use Schedule 40, but the 80 you can. And then EMT, that's the thin wall electrical metallic tubing. It's this conduit here that what you had. How many of you have done conduit bending either with Carla or me or Jay? If you have, you were bending EMT. EMT is electrical metallic tubing. It is the thin wall. It's the thinnest of the three. With the machine, you got a machine over there. So you've done some research. I haven't even seen the machine yet. Right. So yeah, the rigid, it would be rough doing it by hand. Yeah. Yeah. And RTRC, I have to see what that is, and then other approved means. Here, your inspector or your authority having jurisdiction, that will be the local electrical inspector, just down at the on Rowan Road. If the inspector determines that the raceway is not subject to physical damage, then Schedule 40 PVC can be used. I got Schedule 40 in here, but you got to the way to clear yourself from having to do a job twice would be, when you plan a job, you want to jot down the materials you're going to use, Schedule 40 this or whatever. And when you go to actually buy the permit, or whoever goes to buy the permit from the inspector, show them your plans and say, I want to do this job here. That's what I'm here to buy a permit to do. And do you approve of all these materials for this particular job? And then let him go through what y'all discuss. He can tell you if he objects to something. He'll ask you questions like, is it subject to something run into the conduit? And then you answer those questions. Other than service interest cable, individual open conductors and cables other than service interest cables must not be installed within 10 feet of grade level or ground, or where exposed to physical damage. Cable supports for service interest cable. Here they're showing must be supported within 1 foot of your weatherhead, gooseneck, or raceway connections at the enclosure, and the interval is not exceeding 30 inches. So You can't go any, you gotta be, you gotta have it supported within the first foot. After that, every 30 inches maximum. And where exposed to weather, your raceways enclosing your service conductors must be listed or approved for use in wet locations and arranged to drain. Where they're embedded in masonry, they shall be arranged to be able to drain. And so here, they're actually showing a cable. This is not even in conduit. That's an ELC cable, service entrance cable. That's just pulling cable that's coming out of their straps. And they've actually just got it bent. They got it bent over like a weatherhead, but it's not even a weatherhead. It's just a cable itself being bent. If it's rated for outdoor, you know. And then they taped it on the end, a self-sealing weather-resistant tape on the end of the cable where your conductors come out. I've never actually I know where that's a friend of mine that stays over on D Street. You might know where D Street is. It's over behind, you know where the old Triangle Motors is. There were, you know, 701 Business, you had to run the Sandpiper. If you're on 701 Business, you get to where there was there's an old car dealership over on the left before at the light. And when you go around that curve, you get over to Sandpiper. Anyway, right across from that old dealership, look over that way, and there's an old store, and there's a guy that does appliance repairs over there.
Oh, you're Clinton Funds. That's the other Clinton Funds.
Oh, it is. Okay.
Right, so I said behind the carpet cleaning people.
It's a warehouse over there, right there at the light. You
pass Sandpiper, and then there's the
oh, it's past Sandpiper. I'm talking about way before Sandpiper. When
you're which way?
If you're at say at Carly Season, you're heading out before Sandpiper. When you get out there at the stoplight, before you see the curve to go to Sandpiper, at that stoplight, as soon as you go through it, right there where that old dealership used to be,
yeah,
you turn in right there, and then there's an old like a strip mall there, and there's a guy that does appliance repair there. You circle around there, and anyway, a friend of mine stays over there. It's an old house, and that house has got cable, service entrance cable coming up out of the box. It's actually strapped to the house. Like it's not even in concrete. It's been painted with the house. They're painted it white. Yeah. It's all wiring. This is the original wiring in the house. It's old. Yeah, but my friend that's there, he's been renting that house for a long time. He's the guy that owns it, does just what needs to be done for repair. He's not going to rewire it. He might not rewire it. Above the point of attachment, your weather heads must be located above the point of attachment for service drop or overhead conductors. Right. So obviously the service head has to be above this. It's got to be within 2 feet of the point of attachment. And your service head, your weather head has to have separate openings for the conductors. And it has to include drip loops for rain to drip. So you'll notice there'll be a drip loop where your service entrance is. They do it that way so when the rain hits it can drip and not go in the weather head. It can't go in the weather head. Let's back up. You know, when you have a loop like this where it's going down, it's going to drain and drip this way to where the next one is a violation because your connections there, the rain can actually drip into the weather head. So you can't have that. That won't pass there. because it doesn't have a drip leg that's below this. Drip loop conductors must be connected to the service drop below the service head or termination. And so it can just naturally drip. High leg conductor identification. This is something that those of you that have commercial wiring, you've already heard about this. If you have, if the transformer outside that feeds your building, if that transformer is a delta transformer with a high leg, what they call a high leg, which is not common. It's not common, but every now and then you may see one on older things. I don't know of anything on newer buildings that's done like this. That's like this. If it's a delta transformer in the yard feeding your building and it has what they call a high leg, the high leg needs to be orange. And the reason they call it a high leg is because if you take a voltmeter and you measure from, say, from the black wire, the first one, from the first one to neutral, it'll read 120. If you read from the blue wire to neutral, it'll read 120. If you read from the orange one to neutral, it'll read 208. You can't use the orange conductor on single phase receptacles and lights because it will actually burn up. You can't use the orange leg on regular receptacles and lights and things. It can only be used for motors. When you use all three, of those, the funny thing is, if you read, say from black to orange, or black to blue, or orange to blue, in relation to each other, you'll get a standard reading like you're supposed to, a 208 or 240. It's okay. The problem is from the orange leg to neutral, it will read high because of the design of the transformer. Without getting into that, we'll get into that stuff that'll show you the reason. How many of you have had commercial wiring? Okay. Don't even worry about the reason why it is that way. Next semester, I'll teach you that, and I'll show you a picture of why the high leg is high on that transformer, why it is. You don't even know why it is, you just need to know that it is. Another thing is when you have power like that feeding a breaker panel, that has to be a sticker inside saying that there's a high leg in there, and you have to identify which one, and that you're not allowed to use that high leg for single phase loads. If you do, you're going to burn something up. And they say it's happened before people, and I wouldn't doubt it. Now, strangely, it's not strange, but on your service equipment, where it comes in from the power company, the high leg has to be on the third leg out there in the yard. The reason for that is whenever you plug in your meter, when the meter base plugs in, it keeps up with your kilowatt hours. The meter base uses the first two phases. It uses the A and the B, the L1 and the L2 phase to actually power the meter base. Therefore, the high leg has to be on the third one because the meter base itself uses the first two. Now, when you get to the house where you're feeding to or building, for some reason, they want the high leg to be in the middle. They want it to be in the middle on the L2 phase. I don't know why they didn't just stay in keeping with the third leg there, but they didn't. And you see that difference, and that's what's actually, what's required. You may never see it. You may never deal with a situation like that, but if you do, you will at least have seen it one time in here. Part 5, your service disconnects in general. Your energized parts must be enclosed and guarded. Barriers. Barriers must be placed in service equipment so no uninsulated phase conductor, service bus bar, or service terminal is exposed to inadvertent contact by persons or maintenance during servicing load termination. So see, there's a cover up here. Now that's the same kind of panel I got at my house. That's a Generac panel. It's a transfer switch for a Generac generator. Yeah, it is. Yeah. If you look up here, guys, the wires coming in here to that transfer switch, those are the ones that come from the meter base that stay hot all the time from the power plant. So they come from the meter base, and instead of it going straight in your house, they remove them out of the house and they run new ones into that transfer switch. And that becomes your service equipment. Is that transfer switch is service equipment at that point. And it has to have a guard on it because these wires, you can't cut them off. They're hot from the power plant. Unless you pull the meter base out. You pull the meter base out and then you lose power from the whole house.
Yeah, Barry, certificates on that stuff up while it was hot. And he blew a couple fuses and switchboard and that. But yeah, we got it.
Period. But yeah, it is, yeah. The guy that put mine in, he pulled the meter out and did all the connections, and then you put the meter base back in.
That's probably a fair thing to do right
Mm-hmm. Yeah.
there. I asked her, any other way to do it? They said, I don't think there is, except for get connected and everything.
Right. Marking your service disconnect. So that's where it's marked as service rated. That's, you see where your meter base is feeding that, and that's the way that goes. That becomes your service equipment there. Meter sockets. Meter sockets must be listed and rated for voltage and current rating of the device. Surge protection. All services supplying dwelling units must be provided with a surge protective device. The location of it. Now this is one that actually snaps in to where a breaker would snap in. It would actually snap in on the load side to pop right in place there. It must be an integral part of the service equipment or be located immediately adjacent to the service equipment. So that's the type that can actually be snapped into the panel like a breaker. It's permitted to be downstream to panel board, so that's where you can have those in like in breaker positions. Your surge protective device, which is abbreviated as SPD, must be a type 1 or type 2. Whenever you replace service equipment, then you have to put surge protection in there now. It's actually 2020 code now. The new code says you got to have it. Part 6, service disconnect. Disconnecting means the service disconnect, it must open all of your phase conductors, all of your hot wires. Must be readily accessible. So the disconnect must be located at a readily accessible location, either outside or inside, nearest the point of service conductor entry. They must be limited in length if they're inside the building because you don't have protection for it because it's coming straight from the power line. And so here, they've got the meter base outside and they're running through the wall. That's like it's done at my house, it's running straight to the wall. And your service, well, actually now my service disconnect is outside and inside is like a sub panel there. It's considered to be a sub panel. But they want it to be short, very short, the ones that come straight from your meter base, because there's no, you don't have any fuses out here. It's straight off the power line. There's what?
There's another length of wire that they're
There probably is, let's see.
One time, they had a college inspector out there that, you know, paid to make it a little bit longer.
Yeah. Yeah, it probably, I'm sure it listed in there somewhere as far as the limit. I don't see it yet. But somewhere in 230, you would, it's probably going to be listed in there. Some local jurisdictions have a specific requirement as to the maximum, so that could be by county. Just some.
Yeah, because they called the inspector out there.
Yeah. Yeah, and it's going to be based on what county you're in. The inspector here may say one thing, but in a different county may say something different. If they're given the leeway to make a decision, they're all of them might not say the same thing. Bathroom areas, you can't put a service disconnect in the bathroom. I can't imagine somebody doing it, but they're telling you you can't do it. I guess somebody might have tried at some point, but remote control. The service disconnect, not a remote control device, must be located at a readily accessible location, either outside or inside near the point of service entrance conductors. They must be permanently marked for as a service. It should say it. The number of disconnects, each service must only have one disconnecting means except listed in that article. If you get two to six of them, you can permitted by those article numbers. But no more than six for each service. But a building, you can split it up and do two services and do 6 per and have 12 on the building. You can do it that way, but no more than 6 per service entrance. Yeah, they're saying right here. You got that's a transformer like out here in our yard. The transformer pad feeding the building. The transformer is where you would have that delta or that Y transformer that feeds the building. And I was referring to is a secondary winding on that transformer. Is it in a delta pattern, which is like a triangle, or it just look like a Y? The windings. It's like a motor, like a 3-phase motor. The 3-phase motors are a Y or they're delta. The secondaries on transformers that feed the building from them big boxes out there, they look like motor lines, and they'll either be Y or delta. And they must be grouped and marked to indicate the load that they serve. Okay. To minimize the possible, the camera went off. Why did the camera go off? I wonder how long that's been off. Darn.
Well, they got this slide to get back to.
Huh?
They got the slide to look at.
Yeah, that's true. Yeah, I just didn't want somebody to be in the dark, with to minimize the possibility of interrupting power for things like fire pumps, emergency systems, legally required standby systems, or optional standby systems. Then you can have additional service disconnects. Manually or power operated, the disconnect can consist of a manually operated switch or a power operated switch that can be opened by hand. And down here where it says a shunt trip control, the push button is not a disconnect. Now a shunt trip is this. If it's a button, and I'm wondering that's probably what that is. That button right there going into there. What a shunt trip is this. we had one on the machine that come from Italy. We had a automatic welding machine that was the disconnect on the panel. What it would do is if someone went into the control panel, not the breaker panel, but the control panel on the machine, not the breaker panel. But if you took the door for the panel that had the PLC control and all the control lines for the machine, if somebody went in there and opened that door up with it running, there was a limit switch on the door, and when you open the door, the limit switch would actually activate the shunt trip, and the shunt trip would actually trip the main breaker. It would actually trip the main breaker and kill the power of the machine. So there's no way you can go in that panel and you can get electrocuted because it would actually cut itself off. It would actually trip. So a shunt trip is basically, it's a coil. It's a coil like on a motor starter. It's a solenoid type thing. What you could do, yeah, when you're troubleshooting, here's what we had to do. You would go in there and not in the breaker panel, but in the machine panel. You would cut it off, open the door, and you would go where the limit switch is. And if you pulled it was a button on the limit switch. And if you pulled it towards you, it would actually bypass and defeat that switch. And that's what we had to do. But the little limit switch had a plunger on it, and when the door closed, it would make the limit switch, and it would allow you to reset the breaker. The breaker was actually coming out through the front door on the panel, and it was accessible there. But when you cut it off and then you open up the panel, you had to go where the plunger was and pull it toward you and leave the door open, and then it would let you cut the breaker on, and you in there with the panel and everything on the hot. So, but that must be, I think that's probably going to be a shunt trip for that main right there. For that main. And somebody asked me before, have you ever hit that before? And I said, no. I said, well, let's hit it, see. I said, why? I don't know. No, we're not going to do that. I'm not sure what it's going to take. Some people just want to see what's going to happen, and they don't care about consequences, it will probably just kill what's in this room. But actually, no, there's actually more things outside the room wire that too. So anyway. But that's what a shunt trip is. It's something that will electrically trip something instead of you having to manually do it. Your service disconnect must have an ampere rating not less than the calculated loads that we went over back in 2020. For a branch circuit, a disconnect must not have a rating less than 15 amps for a branch circuit. For a 2-wire branch circuit, no less than 30 amp disconnect. For a 1-family dwelling, your disconnect must not be rated less than 100 amp 3-wire. All other installations, no less than 60 amps, maybe like for a workshop or something like that. That's outside. Only the following electrical equipment is permitted to be connected to the supply side of your service. Transfer switch, meter sockets, and they must be labeled. A meter disconnect switch must be field marked. This is a meter disconnect, not service equipment. Conductors for legally required and optional standby power systems, fire pump equipment, fire and sprinkler alarms, and low energy management devices can be connected to the supply side of your service disconnect. So here, when you see something in red, that's typically going to be like for sprinkler systems or some type of a specialty system like that. They'll be painted red or or orange. Conductors for legally required, these systems here, you see where they're tapped in? They're tapped into the top, not the bottom. So where you coming in from the power company up here to the top of that main disconnect, that emergency system right there is tapped in up top. So that if your service disconnect gets shut off, it will not affect, say, the sprinkler system or something like it. It'll be, they're going to get power straight from the power company with no way to interrupt it. The same thing for photovoltaic for your solar equipment outside the house. Those wires are running straight through, and they're coming right off of the meter. The meter base, they're feed right off of the meter base with no breaker in there. So they're coming straight off of that, straight through. Well, no, they're coming straight. It's a disconnect just for this system. So here, they're coming right off of the meter base with their own disconnect for the photovoltaic system, to where the house would have its own coming off of the meter base as well. So they have their a separate disconnect. I've never heard of this. I've never heard of a meter mounted transfer switch. You see anything like that with working with Andy? I've never heard of that. I didn't know you could put something like that in there, and it would be could even fit in a little area like that.
So would that be just something you don't have that area to mount a transfer switch?
I guess so. That might be it, man.
That's for just photovoltaic, or could that be for a generator too?
That's a new one on me. I've never seen that.
Space on like
Mm-hmm. Yeah, that's unusual. I almost wouldn't want it in there, because if something went wrong with it, you'd be dealing with the meter base. You know, it would be. Yeah, I don't think I'd like that. It's too. Yeah. Mm-hmm. 1 and 2 family dwelling units, all your service conductors shall terminate in a disconnected means having short circuit current rating equal to or greater than the available fault current installed in a readily accessible outdoor location. If more than one disconnect provided, they shall be grouped. Part 7, overcurrent protection. Where required. This is where your meter base plugs into those sockets right there. So this is what it looks like if you take that round meter base off, you unplug it from the box. That's what it looks like behind it with those quick connect female stabs in there. Those of you that are doing residential, how many of you are working? We're calling right now, taking residential. In that room, if you go all the way to the right, all the way to the back, and I think the trainer that's on the left at the very back end, you might not even be working with it. That trainer has got a meter base on it. It's got the glass meter base with the wheel. Now, if you go back there, and you can pull that thing out. If you want to go back there and grab a hold of it with both hands, wiggle that meter base, the glass part, and pull it straight out, and you can see it's going to look like that behind on the left. And it actually it plugs into a quick connect with those copper bars in there. If you never took one off, you can go out there and try it and see what it looks like. Mm-hmm. It's the only one of it that's got it, and what it is, the chairman that was over this department, Mr. Meredith, Dana Meredith, that was here when I came in. He bought a residential trainer from some company. He bought one, And it came with a service district. Then he decided to build a bunch of them here instead of buying them ready to build. And when they build them, they get to put service districts on. So it's the only one over there like that. It's got a weatherhead and everything. And so it was at the back of the room. There's 20 trainers over there. And you got the new ones up front and then the older ones in here. So it's all wet back. But coming in from the meter base there, here you've got a disconnecting means here before it goes into the house. And that's for both of your phase conductors. The neutral doesn't go through a breaker or the ground. It's just a hot wire. And the rating of that device, it cannot be greater than the amp rating of the conductors. So here they've got an 800 amp disconnect, breaker disconnect, a calculated load of 750 amps. And the conductor rating, they're using two 500 kc mil wires rated at 380 a piece, which equals 760. Now here's an exception. The wires combined are rated for 760 amps, but the breaker, the disconnect is rated for 800, is rated for more than the wire. It says here where the amp rating of the phase conductors does not correspond with a standard rating of overcurrent device, they don't make a 760 amp disconnect or breaker. The next higher overcurrent device can be used if it doesn't exceed 800 amps. And that comes from Article 240.4. So you can go to the next higher size breaker. You can. So here you've got a difference between a 40 amps between 760 and the rating of the breaker, which leaves room for a little bit of room for danger there, but they allow it, you know. The combined ratings of 2 to 6 overcurrent devices can exceed the conductor ampacity, but the calculated load must not exceed the ampacity of the service conductors. Okay. Overload protection for 122 40-volt 3-wire single phase dwelling services is permitted to be in accordance I don't have any extras. Student services got some. I run out. If you go over to the north building where you register, okay.
We staple it for you.
Hold on.
Is that on?
Thomas.
Tell me to staple it again.
So you can staple it again. You staple it. Yeah, I had a box. I bought a box, and then we run out. I ain't gonna buy no more. It's just they're giving them away over there. They give them away. I was buying them out of my own money. No, they got them free over there. Yeah, yeah. Maybe he's got some. Right. The medical. If you go down the hallway, the people teaching the ENT stuff, they probably give you one. If you find a classroom down there, somebody that's teaching medical stuff, right down that hallway. I got one from them the other day. It's time to stop. Okay, so we're almost done with 230. I did put a worksheet in Moodle that covers Article 240 and 250. That's the last worksheet for Chapter 2. We're going to do a test on Chapter 2 fairly soon. And I know we haven't had one in a while, but this is the first time that I've taught this class, and it's hard to tell kind of how to pace it and to know where we got to spend time at. But I can tell you right now, where we're spending time at, we're supposed to. We're supposed to. And I don't know how far we're going to get in the book, but we can't help that if we don't get as far as we're supposed to. We set out to do. They only give us 55 minutes for 2 days a week. We needed, I'd ask for it to be 3 hours next time. 3 hours.
They can think about the calculation test or have them.
Yes, we will. Yeah. You'll be fine as far as calculations, but you'll have an introduction, but you won't do a lot of it, and you won't be doing like calculation worksheets like you will.
I think I'll take the code class whenever I get enough hours.
Right.
I just want to get something big.
Next summer, when we do the calculation class, there'll be a lot of repetition, and your worksheets are going to be doing calculation. We'll be doing,
I'm not going to be here.
you won't be here yet. Yeah. You can take a class like Jerry Burks up in Raleigh, my friend told you about.
Yeah, I'm probably going to do something like that.
That's what I would do. He's good.
I'll probably either go with him or the guy that he.
Yeah. There's several out there that are doing it within driving range. There's a guy in Wilmington doing it. Somebody in Fayetteville's doing it. But I got connected with Jerry originally by this school, and I stuck with him because I know he used to work on the state board. He used to actually write exams years ago. He was on the board that actually wrote exams that you take to go get licensed. No. Hey there. How about that? How you doing? So anyhow, I'm gonna stop the video. Whoever, if there's anybody watching the video, if you have questions, contact me and I'll be glad to help you. And you have a blessed weekend.